So now that we have covered the key core concepts that are necessary to understand the concepts relating to bearings, we're going into segment 4 now, which deals with bearings. I'm sure by now you would have heard about the idea of bearings. So I could ask you, what comes to your mind when you think of the concept of bearings, or the idea of bearings, or what is a bearing? So let's just go ahead and verbalize a quick definition. So a bearing is a direction of travel given as an angle measured clockwise from north and is represented in 3 digits. A very simple yet compact and complex definition, taking in all angles of the idea of bearings. So as we expound on that definition, let us look at the characteristics of a bearing. What are the 3 main characteristics of a bearing? Well, 1, the basis of a bearing is at the north direction. Number 2, it is always measured clockwise. And number 3, it is written in 3 digits. Now, bearings is actually one of the aspects of mathematics that really shows application to everyday life. We're talking about planes flying in the air, and in order to arrive at their destination, bearings are important to give them that direction as to how to proceed. Ships in the sea also are required to sail on a particular bearing in order to head in the direction of a particular island or space that they intend to dock at. So there's a lot of application of trigonometry, in particular bearings, in particular as it relates to travel and so on, and the relationship, the relation in terms of distance from one place to another. All right, so let us see if we can give a quick overview of what we do when we're solving problems relating to bearings. Well, first, we should be able to choose the trig formula that will help us to find the length of the side that we need, or the size of an angle. And I'm saying side here because once we are given our question or situation, we can go ahead and formulate a triangular representation of what the data is saying to us, and based on our sketch we can determine the size. We can have a marked letter that we use to identify the angle that we intend to find, as well as using a variable to label the side that we intend to find. So we must choose either Pythagoras' theorem if it is that we have a right triangle, the sine ratio, cosine ratio, or tan ratio if it is that we are working with a right triangle, or the sine rule or the cosine rule if it is that we're working with non-right angle triangles. And based on the type of triangle we have and the information that we will need to handle, we will be asked to determine which of these will be best suited to answer that question. And then we go ahead and substitute our information that we're going to be needing to simplify our approach, and then we go ahead and solve, especially in the case of an equation. So in this particular case, we're going to solve to find the length of a side or the size of an angle. So stick around. So again, looking at the key components of bearings, it is always measured from north, measured in a clockwise direction, and written using 3 figures. So in the shape to your right, we see that that point is on a bearing of 60 degrees, written as 060 degrees. Next is on a bearing of 145 degrees, written as 145 degrees. Next, a bearing of 230 degrees, and again we're coming from north, so we start at that north line and we come all the way around to the measure of the bearing or the angle that we're referring to. And the final picture there, coming from north again on a bearing of 135 degrees. So it's a good idea to remind yourself of how to use your protractor. A protractor is used to measure your angles. Usually have one in your geometry set. A 360 protractor is good when you're measuring bearings, because then you don't have to measure 180 and then stop and measure again and add to it if we're going beyond that distance. But if you don't have a 360 degree protractor, then you can always utilize the 180 that you have and manipulate that to find out the measure of your angle. Alright, so I'm just going to show you a demonstration of how to use your protractor. So this is just a reminder of how to position your protractor to measure the size of an angle, and we're talking about not the reflex angle this time around, talking about the obtuse angle in this case. So you're going to put your protractor at the center of the protractor at the point where the two arms of your angle are formed, and you make sure that your baseline for your protractor is placed along one of the arms of the angle, and then you go ahead and measure in a clockwise direction from 0. In this case, we're reading off an angle of 115 degrees. Right, so when we are recording our bearings, we always have to pay attention to where we are starting from. So in this particular demonstration, we're to find the bearing of B from A. So of course, we're going to set up our cardinal points at A, and we are going to connect point A to point B, and then we are going to measure the angle from the north line of A, where it forms with the line joining A to B. So the arms of our angle of measure is going to be the north line and the line connecting A to B. So in this case, the bearing of B from A is 060 degrees or 60 degrees. Now we are measuring the bearing of A from B. Alright, notice we're going from B, so at this point we will set up our cardinal points at B, because that's where we're starting from. And of course we have our line which connects B to A, and we have our cardinal point set up at B. So now we are going to measure the angle that goes from the north line of B all the way around to the line which joins A to B. And again, we are going in a clockwise direction. So do you see that this angle is greater than 180 degrees? And in this case, the 360 degrees protractor works. If not, we go ahead and we know that that straight line measures 180 degrees, and so we measure the additional distance from that south line going around to the line which joins A to B. All right, and in this case we have a measure of 240 degrees, again going from north, going all the way around until we are in line with the line which joins A to B. So in informal definitions, a bearing is a way of defining direction as an angle measured from due north in a clockwise direction. And again, bearings are always written in terms of 3 digits. And when we say the bearing, what is the bearing of B from A? What does that mean? In layman terms, if you are at A and facing north, by how many degrees must you turn in a clockwise direction until you are facing B? So that's the idea behind the concept of the bearing of one point from another. So when our bearing is a reflex angle, we try to get the angle between 0 and 360 by adding or subtracting 180. So let us look at this question. A soldier walked from his base for 4 kilometers on a bearing of 060 degrees to a point A. He then walked a further 5 kilometers due east to a point B. Find the distance of point B from the base, the bearing of B as measured from the base, and the bearing of the base as measured from B. So let us start this question by identifying our base. So from our base, we are going to be setting up our north line, and we are going to travel for a distance of 4 kilometers on a bearing of 60 degrees. So once we would have set up our north line, we're going to use our protractor to measure a bearing of 60 degrees and extend the arm of that angle to represent 4 kilometers. And then we stop. The point at which we stop, we label that point A. Then we continue from A going east to B, a distance of 5 kilometers. So at A again, I'm going to set up that north line. And of course, we know that east is going to be that 90 degrees from that north line because it's directly on our cardinal point. So we're going east 90 degrees from A for 5 kilometers, and that takes us to B. Upon completing our sketch, our diagram looks like this. It forms a triangle, and we have, for our triangle, we have 2 of the sides and the angle formed between those 2 sides. So which rule would we use to solve this problem? Because our aim now is to find the length of the third side, which is the distance of B from the base. You are correct, it is the cosine rule. So we have 2 lengths of the sides, one being 4 and the other 5, and the angle which is opposite to this side that we intend to find is 150 degrees. Let's go ahead and look at this calculation now. So now let's turn our attention to the second part of the question, the bearing of B as measured from the base. Now the bearing is going to be the measure of that angle which is formed between the north line at the base and the line which joins the base to the point B. Alright, so let us go through a process of elimination to determine which approach we will use. So we can't use Pythagoras' theorem because we don't have a right triangle. We can't use the ratios, sine, cosine, or tangent as well because we don't have a right triangle. If we're going to use the cosine rule, it must be that we're given two sides and an angle and we wish to find the third side, or we're given three sides and we wish to find the sides of the angle opposite to one of the sides. Which is in fact the case here, but there's more than one method that we can use at this point to find the sides of angle theta. So the cosine rule can be used because we have three sides and we need to find the angle opposite to one of the sides. We could also use the sine rule here as well. Sine rule can be applied because we have a side and the angle opposite to that side, and we have another side for which we need to find the angle opposite to that side. So the sine rule can be applied here. So we will go through and use both methods and we'll see if we will arrive at the same angle in terms of size. Here's an alternate approach. So here is our result using the cosine rule. What did you notice? So again, here we are now required to find the bearing of the base measured from B. So again, we're going to set up our north line at B, and we're going to measure that reflex angle that comes from the north line all the way around to the line joining B to C. Okay, so we can measure the angle between the south line and the line which joins B to C, and we know that the measure of the angle going from the north line to the south line is 180 degrees. Additionally, we could use our knowledge of the angles formed when a transversal cuts two parallel lines. In this case, the north lines are the parallel lines and the line joining B to C is the transversal. So in this case, we see the angle NCB is alternate to angle CB, and where S would have been the south line there. Alright, so without measuring, we could have figured out those angles using the property of alternate angles. And we know that alternate angles are equal in length. Alright, so by our calculations, the bearing of the base as measured from B is going to be 77 degrees plus 180 degrees, which is 257 degrees. So that takes us to the end of today's session. I'm leaving a question with you. You can work the question out and leave your answers in the chat, and definitely I will respond to you to see how accurate you are. Alright, so that's it for today. Try this question. Let me know how it goes. Take care.